This is actually a demo that I included with my geometry course. And we have a person that's over here, and I can move that person around. And that person is looking at this object in this mirror. Okay, and so no matter where I position the person, no matter where I position the object, notice that the rays from the object are bouncing at equal angles, and this is the ray that ends up in this eye, and this is the ray that ends up in this eye. Notice that if this person takes the light as it comes into his eyes and traces backward, he could have the object hidden. He's not looking at the object, he's looking over here somewhere. And where his eyes are focusing is at a point behind the mirror. In fact, that'll be a point equal distance on the opposite side of the mirror along a perpendicular here. So this is the image point, mathematically speaking. So wherever you put the object, the image will be straight across the mirror. And from any person's point of view looking at that object in the mirror, it'll appear that they're looking at a point behind the mirror. If I trace backward along the line of sight for the light coming into my eye, it'll appear to be coming from a point that's beyond the mirror. The fact that there's actually no light over here at all the light's out here in front of the mirror, and this is just an imaginary image back here. This is called a virtual image. It's only where the light appears to be coming from. Okay, one question people sometimes ask is how come if I have some writing and I show it in the mirror, it goes the opposite direction. So here it's going right to left instead of left to right. But notice it's not reversed top to bottom. Why should it be reflected left to right and not up to down? So if I look at this again, look what I do when I show it in the mirror. Look at this, I'm turning it. And what you see in the mirror is a turned version of the image. Isn't that interesting? Would you expect any different? What if I take the original and I turn it this way? And now it's reflected top to bottom. Okay? So, there we are. So what if I showed it in the mirror without turning it at all? So like here's the view. I'm just going to put the white on the other side so that, see, you need the white to even see it because it doesn't show up against the background. But if I just put the white on the other side and don't turn it at all, look what's happening. You're getting, everything is totally readable. All right. Put the white behind and you can see it here. And then just put the white in front. And you can see it there. All right. So what's really happening is every point on the object is reflected straight across to an equal distance behind. So this point over here is reflected across here. This is reflected across here. And if it reads left to right as seen from my point of view over here, it's going to read left to right as seen from my point of view over there, because they're just translated, okay? Now, if something has three-dimensionality to it, like you take my hand, notice my fingers are closer to the mirror and my thumb is farther from the mirror. This little finger is over that side, my thumb is over on this side, but my thumb is farther away and it looks farther away on that side too. So it inverts things front to back, but it doesn't turn them side to side or up to down.